Results of 2 EPA studies distributed recently have changed our notions of why underground storage tanks leak. The first study disclosed the percentage of unprotected steel tanks leaking was almost identical to fiberglass tanks. The 50-state release incident survey of 12,000 leaks found that structural failure, not corrosion, is the primary cause of release. Tank strength may be shown in several ways. A simple test is done with air pressure. Gauges are attached to the tank and a compressor hooked up. When the tank is covered with soapy water, leaks will appear as bubbles. Air tests show only that the tank has been manufactured to standard and delivered without damage. More sophisticated tests can be done with strain gauges and meters. Others use sonic sensing. In some, you can hear the tank ripping under the heavy loading of the product in it. There's a test which demonstrates the relative structural strength of tanks. We placed a standard 10,000-gallon FRP tank on a pea gravel bed for additional support. A steel tank was simply set on unprepared, unlevel ground. We installed fill pipes with fire hose couplings and vents on both tanks. Standard dipsticks, weighted to keep them from floating, were put in. Neither tank is ever installed under these conditions. In the 50-state study, structural failure accounted for 52% of all tank releases. Only 36% were corrosion-related. Corrosion was cited in 10% of FRP tank failures. This tank is corrosion-protected. The 20-year STI focus on corrosion prevention and the resulting P3 program has been very successful. Ongoing studies and calculations show that the P3 will be corrosion-free for generations. Proper backfilling is crucial to the strength of underground tanks, but geotechnical stresses, frost heaving for example, can disturb even the best backfill. This test demonstrates the difference in the innate structural strength of steel and FRP tanks, which is a vital first step in the protection of the environment. Tank manufacturers' instructions warn against filling before burial, but once underground, the performance of these two types of tank could not be easily compared. The EPA says that 35% of underground fuel tank systems in service would not pass a tank tightness test. As tanks near the bursting point, they may deform. Not only can you hear the tank ripping apart, you can see it. This tank has deformed more than 6 inches in diameter and may fail at any time. The steel tank has deflected only half of 1%. No product was released. The FRP tank ruptured in less than 30 minutes. It could not contain the amount of product it was manufactured to store, even though it exceeded the applicable UL standards for strength. One could conclude that maybe tank design standards need to be upgraded in response to the EPA studies showing the leading cause of leaks is structural failure.